SSC Math with Sujataji. Now let us study the topic second, basic proportionality theorem. Okay students, welcome students in our channel. So let us study the second topic, basic proportionality theorem. Students, this theorem is very useful for your examination base. This theorem is also known as the BPT. Okay, BPT means the basic proportionality theorem. What is the statement of this theorem? The statement of this theorem is, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Okay, so as per the statement, we draw the figure. First we draw the figure, that is, there is a triangle, so we draw the triangle ABC. There is a parallel line, and that parallel line is of this first line, that is the first side of the triangle. Suppose that line L is parallel to line BC. And then we can say that this, if you take this point P on the side AB and Q point on the side AC, then the sides in the line, this line divides the side in the proportion. That means it divides AP upon PB, and that are equal, that means AQ is equal to QC. So here from the figure we write the given. That given is, in triangle ABC, line L parallel line BC and line L intersect AB at P, line L intersect AC at Q. But this much is sufficient in the given. Now we have to prove that AP upon PB is equal to AQ upon QC. This we have to prove. Now here there is only triangle, there is a line which is parallel to the one side, but this such information is given by the statement. So students, this figure is insufficient to prove. So here is a construction. We do the construction, that draw segment PC and segment PQ. Here say draw segment PQ and the PC here. So that's why we have the this one, and this one, that is the triangles. And as per the given triangle, we can prove this theorem, students. Okay, so here see in the next one part, that the proof in triangle APQ and PQB. Students, proof, we divided the proof in three parts. Okay, that is from the left hand side of the figure, that take the two triangles, and on the right hand side of the triangle take the two triangles. Okay, and then at the lowest side of the triangle take these two triangles. So that means the first part is that take the triangle APQ and triangle PQB on the left hand side, and they have the equal heights. Students, and that means we can say that area is proportionate to bases. Area is proportional to their bases. So that means area of triangle APQ upon area of triangle PQB is equal to AP upon PB, and called it as the first equation. Now this first part is over, students. Now the second part, that this one, consider that only this one is a second part. Okay, for our easiness only, students. Second part, that is the right hand side triangle. So choose this triangle. In triangle APQ, triangle PQC have equal heights, have the triangles equal heights, and that means area proportionate to the bases. So students, area of triangle APQ is equal to area of triangle APQ upon area of triangle PQC is equal to AQ upon QC, and call it as the second equation. Now here second part is over. Now students, take the triangle on the bases, at the basis level. That means the triangle PQB and PQC have the common base, student, and here if PQ and BC are parallel sides, that means we can say that these two triangles have the equal heights also, common base and the equal heights. That means we can say these two triangles are equal, areas of these two triangles are equal. So area of triangle PQB is equal to area of triangle PQC, and call it as the third equation. So now students, from the equation 1, 2 and 3, we can conclude that area of triangle APQ upon area of triangle PQB is equal to this, will be is equal to area of triangle APQ upon area of triangle PQC. Okay students, but here Now APQ and PQC both are equals. Okay, so now here from this, by the ratios of areas of two triangles, their ratios are AP upon PP is equal to AQ upon QC. So these students see the property of an angle bisector of a triangle. So there is a theorem for this property. So statement is the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Okay, so that means here there is a triangle. So we draw the triangle ABC. We draw the triangle ABC, and here there is a bisector of angle. So we choose the angle C here. Okay, we choose angle C, and so that's why we draw the angle bisector. So this is the angle bisector. C is the angle bisector of the angle C here, student. So that's why these two triangles are equal. That means the angle ACE and angle BCE are equal. Okay, and here what we have to prove it? We have to prove it that the opposite divides side opposite to the angle in the ratio of the remaining side. So now here opposite sides AE, AB, EB, AE and EB. So their ratio is AE upon EB. Okay, this is the angle bisector and opposite sides are AE and EB. Their ratios are AE and EB, students. Okay, and that is equal to the remaining side, ratios of the remaining side. So remaining sides are CA and here CB, students. So the ratios are CA upon CB. So that means we have to prove that AE divides AB is equal to CA divides CB. So from the statement, we first draw the figure. From the figure, you write the given, and then from the statement, you write the to prove, students. Now here, this only there is a triangle, and that triangle is insufficient to prove this. So we construct this triangle, this figure. So we construct that. That means the draw a line parallel to a ray CE. So there is a line, and that line which is DB parallel to the CE. Both lines are parallel to each other. That passing through the point B. Which line passing through the point B? And so as it intersect, or you extend this line, this side AC, and that's why these two lines intersect at the point D. Okay, student? So now we are ready to prove this property of angle bisector of a triangle, students. Now see. Proof that is ray CE parallel to ray BD. Now ray CE is parallel to ray BD. So, and we consider that AD, this AD as a transversal. Okay, so that means here, students see here that these two rays, suppose CE and this DB parallel to each other, and consider, we have to consider that AD as a transversal. So that means we can say that the angle ACE is equal to angle CDB. See here, students, angle ACE is equal to angle CDB, and these angles are of corresponding angles. So call it as the first equation, students. Now the secondly, we take the BC as a transversal. We take the BC as a transversal, students. Okay, this one, BC as a transversal. Then what happened? Then we say that angle ECB is equal to angle CBD. See here, students, angle ECB is equal to angle CBD. That means here, these angles, students, these two angles, this angle is congruent to this angle. Okay, students, and these two angles are of the alternate angle, so these are the common one. So here we say that called it as the second equation. And here we know that the CE is the angle bisector. So these two angles are congruent. That is angle ACE congruent to angle BCE, students. Okay. So that means here call it as the third one equation. ACE is equal to angle ECB. Now we have the three equations. So here from equation 1, 2, 3, students. From 1 to 3, that is here angle CBD is equal to angle CDB. Because angle ACE, these angles ACE is equal to angle CDB. And here angle ACE is equal to ECB. So these both angles are congruent. And here as well as this angle ACB is congruent to angle CBD. So that indirectly we can say that angle CBD is equal to angle CDB. That is from equation 1 to 3. So now here see the next part one, that is in triangle CBD. In triangle CBD, upper triangle. Okay. So here we say that these two these two angles are congruent here, students, because this angle is congruent to this angle is congruent to this angle, students, and this angle is congruent to this angle, student. So automatically these four angles are congruent. And here these two angles, this one angle and this one angle, contained in the CBD triangle. Okay, students? And that's why these angles are congruent. That means their opposite sides are also congruent, students. So these opposite sides are congruent. So here we say side CB is equal to side CD. That means CB is equal to CD. So call it as the fourth one equation. Okay, students. And now here the triangle. Take the triangle ABD. Okay. Now the third part, that is take the triangle ABD, students. Okay. So now here in ABD we can say that the CE parallel to BD here. CE is parallel to BD, students. So that's why by the basic proportionality theorem we can say that AE upon EB is equal to AC upon CD. Okay. But here we say that the CB is equal to CD. So here in the ratio we replace DC by CB. Okay. So that's why AE upon EB is equal to CA upon CB. So this, see the next property of three parallel lines and their transversal, students. So about this there is a theorem. The statement is the ratio of the intersects made on a transversal by three parallel lines is equal to the ratio of the corresponding intersects made on any other transversal by the same parallel lines. So here from the theorem statement we draw the line, we draw the figure. Here figure is that there are the three parallel lines. So first we draw the three parallel lines L and N, student. Okay. Then there are the two transversal made the intersect. Okay. So T1 is the first transversal made the intersect AB and BC, students. Then there is other transversal, consider T2 made the intersect PQ and Q1. Okay. So such a way we have the given information. So this information write in the given as per your figure. So this way you draw the figure. Now here line N parallel to line N, then T1 and T2 are transversal. Transversal T1 intersect the lines in point A, B and C. And the transversal T2 intersect the lines in points P, Q, R. Okay. So now we have to prove that this intersect, that is AB upon BC is equal to PQ upon QR, students. Okay. So let us prove it. So the proof is here, draw segment PC. This figure is insufficient to prove that these ratios are equal. The ratios of the intersects are equal. So here we construct, that is draw PC here, and which is passing through the point D here. Okay, students. Then we have the two triangles. First triangle, that is triangle ACP. In this triangle we apply the basic proportionality theorem. Okay. Here this is the triangle which is C. the name of this triangle is ACP, students. Okay. So now by basic proportionality here, basic proportionality, this side is parallel. This side is parallel to AB. So here we say that the AB upon BC is equal to PD upon DC. Okay. Call it as the first one equation. Then the another triangle which we have to got by the construction, that is PCR, this triangle, students. Okay. See here, this triangle. So now here this DQ is also parallel to CR. So by applying BPT here, we have the PD upon DC is equal to PQ upon QR. So call it as the second one equation. So now here see, here is in the equation PD upon DC, and here second equation PD upon DC. So both are equal. That means these two ratios are equal. That is AB upon BC is equal to PQ upon PD upon DC. Okay. So here this way we can say that. So now here that from AB upon BC is equal to PD upon DC is equal to PQ upon QR, because there are the three equations, and from that three equation we concluded that AB here, AB upon BC is equal to PQ upon QR. See here, AB upon BC is equal to PQ upon QR. Okay.